Welcome back to another Daishinfinity video. In this video, we're going to prove the equivalence principle in logic of mathematics. It states that A equivalent to B is congruent or just saying the same thing as saying A and B or not A and not B. Now, I want to prove this to you guys using something called a table in order to prove this formula. So let's just dive right in. A and B are just both mathematical objects trying to describe something. So if A talks about something like 5 is element of the prime numbers, then we can imply that A is a right thing to say, okay? And if A is saying, for example, 5 is an element of the let's say 5 is an element of a set M, where M is 2k, where k is element of Z, which means it talks about even numbers, then A is obviously wrong. Okay, so A can be either right or wrong, and B can also be either right or wrong, depending on what you want to say. So we can group this as A and B and then write it as a table and write all combinations of wrong and right. So we can write wrong, 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 right, right, wrong, and right, right. Okay? So if we have those combinations of wrong and rights, then we can say A equivalent to B, which states that if A is right and B is right, or A is wrong and B is wrong, then the equivalence always holds because on both sides we have the same thing. But if something different is on one side and on the other side, then the equivalence principle doesn't work anymore. Then it's wrong. So if we have the same thing on both sides, then it's right. So we can see this is right and this is right and this is wrong and this is wrong. Okay? I hope you understand what I mean. Okay, now we want to imply A implies B and B implies A, so that we can finally say A implies B and yes, A implies B and B implies A. So what is A implies B? A can be something wrong or right. If something wrong or right goes to something wrong, then it's always wrong, unless you have something wrong going to wrong. Okay? And if something wrong or right goes to something right, then it's always right, since the implication goes from something to something that is always right. I'm sorry if you guys are confused with what I'm saying, but it's actually logically true what I'm saying. So when something right goes to right, when something wrong goes to something wrong, then the implication is always wrong. The implication is always right, since something wrong goes to something wrong. Okay, so it means like if you're lying, then you're lying. So the fact that you're lying is right. Okay, but what you're saying is obviously wrong. But that the fact that you are lying is always right, since you are lying and then after you are still lying, rather than saying you are lying and after you're not lying. Okay, that is what you are saying here. You are not lying and then you are lying. That is what you are having here with wrong to right. If that is true, it is also right. Okay, so you just have to look at the B column. Okay, if something right goes to wrong, then it's wrong, and if something goes to right, then it's obviously right. Okay, now I look at B implies A. So we look at the column A. When something wrong goes to something wrong, it's obviously right, since you are lying and then after you're lying, so it's the same thing. if you're right and then something goes wrong afterwards, then the first B should be wrong too. So B implies A is wrong. And if something wrong goes right, then it's right, since something wrong will be fixed into something right, okay? And then the last thing is, if something right goes to something right, then it's always right, since we have the right thing on both sides. Now, the last part, what we're going to do is A implies B and B implies A. We're just going to take two of those implications and see that both of them should be right so that it's right. If one of them is wrong, if one of the implications over here is wrong, then it's wrong. So we can see on the first space here, we see both of them are right. So it's right. And then we have right, wrong. So one is wrong, so it should be wrong, since one is wrong. And the other and the second one too, the first one is wrong. The implication A to B is wrong, so everything is wrong. And the last one, right goes to right and right goes to right, so it's right. Now what do you see here? We see right, wrong, wrong, and right, right, wrong, wrong, and right. And this is what we wanted to show. It means that in the end, A equivalent to B is the same thing as saying A and B, or not A and not B.